June 19, question number 13. In the diagram below of circle O, chords JT and ER intersect at M. If EM is equal to 8 and RM is equal to 15, the lengths of JM and TM could be. Okay, so this is clearly a problem with intersecting chords. I like to simplify the intersecting chord theorem to two intersecting chords, as I'm drawing here. And when you have intersecting chords, they're divided into four parts. I'm going to call this part A, and this part B, this part C, and this part D. And quite simply, the theorem states that A times B will always be equal to C times D. So now I'm going to go back to my problem. I'm going to look at the given information where it says if EM is 8 and RM is 15, the lengths of JM and TM could be. All right, well, I'm just going to substitute my 8 and my 15 into my theorem and go to my calculator and say 8 times 15 equals 120. So really this problem is asking what could be the other two parts? Which two other numbers multiply to give you 120? So I'm just going to, since this is the multiplication part of the Regents, I'm just going to multiply 12 times 9.5. That's 114. Now I'm looking for a pair that equals 120. So number 2 is 14 and 8.5. 14 times 8.5. That equals 119, almost. Number 3, 16 times 7.5. Oh, and there you go. 16 times 7.5 is 120. We have found our answer. June 19, number 18. In circle O, two secants, ABP and CDP, are drawn to external point C. If the measure of arc AC is 72 degrees and the measure of arc BD is 34 degrees, what is the measure of angle P? Well, whenever they give me a problem that has to do with circles where there's no picture, I'm going to do my best to draw a picture. So I have circle O. Well, circle O technically means that you have a point. The name of the point is O. And around that is our circle. Okay, and now we have two secants from an external point P. So I'm going to put point P out here. There's point P, and draw two secants. Remember, a secant intersects the circle twice, right? It goes in and goes to the other end, and there's two secants in this particular case. Now, the name of the first secant is APB. So I'm going to kind of go backwards and go B, P, B, A. Right? They have to be in that right order, right? ABP or PBA. And the other one is CDP, or backwards is PDC. Well, now I could go and put some of these numbers into my picture. So now it will make a little bit more sense. So if the measure of arc AC is 72 degrees, so arc AC is out here, 72 degrees, and the measure of arc BD is 34 degrees, that's right here. What is the measure of angle P? I'll put a little X in here because we're kind of looking for that angle right there. Well, this, quite simply, the way I simplified the previous problem, I'll do that over here as well. So you basically have a circle and two secants. I'm going to call this greater arc out here. arc A. I'm going to call the smaller one arc B, and we'll call the angle x. So this is a theorem that states that if you take that larger, that greater arc, and you subtract that smaller arc and divide it by 2, it'll be equal to the angle. So I'm going to go down here to my scrap and see in that A position we have 72 degrees. And then I'm going to subtract the 34 degrees and divide it by 2. That should be equal to my angle. Well, 72 minus 34, put that in my calculator, and I get 38 divided by 2 is equal to the angle, and 38 divided by 2 is 19 degrees. Oh, look at that. And there's our answer. Okay, here's a problem that has to do with the equations of circles. Okay, so I see that they kind of have it in a standard form. The equation of a circle is x squared plus 8x plus y squared minus 12y equals 144. What are the coordinates of the center and the length of the radius of the circle? Okay, so here's good practice converting from a standard form to the center radius form, which is a lot more useful. Okay, so here we go. This has to do with completing squares. All right, so I'm going to, on my scrap, just bring down the x parts. So x squared plus 8x. I'm also all the way here on the right side, I'm going to put an equal sign and put down that 144, right? Okay. So now what we're going to do is we're going to complete a square. And completing a square is not that difficult. What we're going to do is take half of the b, which is positive 8, divided by 2, which is 4, and square it. Remember, b divided by 2 squared will always be equal to the c when we're creating trinomial squares. So half of 8, 4. 4 squared is 16, and it's always positive. So I'm going to add 16 right here. But if I add 16 to the left side of the equation, I also have to come over here and add 16 on the right side of the equation. All right. Let's do the y's first before we factor that. All right, so now I'm going to take down the y plus y squared minus 12y. Again, my b is negative 12. So I'm going to take half of 12, which is 6, and square it, which is 36, always positive. And if I add 36 here, I also have to add 36 over here. Okay, now let's go back. Now I'm just going to look at the quote-unquote x trinomial. And this is also really easy to factor once you know it's a square. Once I know that I created a square, I'm going to open up a parentheses. I'm going to bring down the letter, which is x in this case, and then using the same sign as my b and half of my b, which is 4. Close the parentheses and square it. Yeah, x squared plus 8x plus 16 can be factored into an x plus 4 squared. Bring down the plus, open up another parentheses. I'm going to do the same thing with the y's. I'm going to bring down the y. I'm going to bring down the same sign as my b and take half of it, which is 6 squared. And I'm going to say equal here. And now I'm going to go to my calculator and so don't make any mistakes here. And take 144 plus 16 plus 36 equals 196. And we've now converted from standard form into center radius form. Now you do need to remember the form of center radius form. I'll write it up here. We have x minus h squared plus y minus k squared is always equal to our radius squared, when the center is going to be h, k, and the radius is equal to the radius. So let's use that to come back down here and say, well, the center of this circle, remember that whenever I see a negative h in a form, that really just means the opposite sign of the h. So here, my h is going to be, well, I see there's a positive 4, so my h is going to be the opposite of positive 4, which is negative 4. And then I see I have a negative 6 in the parentheses, so I think the opposite of a negative 6 is a positive 6. And I'm going to remember that my radius squared is equal to 196. So I still need to take the square root of both sides to get the radius is equal to the square root of 196. I remember that 196 is a square number, and the square root is 14. So let's go back and see a center of negative 4, 6, and a radius of 14. There we have it. Number 4. June 19, number 28. In the diagram below, circle O has a radius of 10. If the measure of arc AB is 72 degrees, find the area of the shaded sector AOB in terms of pi. Okay, so here we can see we're out of the multiple choice problem, so we need to show all our work. Well, I'm going to remember here that a couple different things. First of all, that the area of a sector is equal to the central angle out of 360 degrees times the area of the whole entire circle. So I like to, on my side of my paper, do a little CARD and see what information is given to me and see if I can figure out the very important area of the whole entire circle before we find the sector. Well, I can see they've given us a radius of 10. Well, that means if you wanted to fill out the rest of this information, we have a diameter of 10 and a circumference of 20 pi. But most importantly, we have an area of 100 pi. Right? If you remember, even in your reference sheet, they give you the area of the circle is equal to pi r squared. So I squared my radius and I tagged on the pi there. Remember, we're giving this answer in terms of pi, so we're keeping pi in the problem. Okay, so now let's see if we can move forward and actually plug all this information into our formula. So we have the area of the sector, which is what we're looking for, is equal to the central angle. Now here they give us arc AB as being 72 degrees. And if you remember the central angle theorem, central angles are always equal to the intercepted arc, which means we also have a central angle of 72 degrees. So I'm going to put 72 over 360, and I'm going to put in parentheses here the area of the whole circle, which is 100 pi. Now, it's not necessary to simplify your fraction here before we multiply this in our calculator. However, if you do want to understand a little bit better what's happening here, if you take the 72 degrees and divide it by 360, and you go to the math button, hit enter twice, which automatically simplifies it, you'll realize that really what we're doing here is asking ourselves, what is 1/5 of 100 pi? And finding 1/5 of a number is the same thing as dividing it by 5. And since we're giving our answer here in terms of pi, 1/5 of 100 is really easy to calculate. It's 20 pi. And that is the answer to our question. The area of the sector is equal to 20 pi. Okay, let's move forward. Okay, so we're going to finish off June 19 with a quick construction. It says, given circle O and radius OA, use a compass and a straight edge to construct an equilateral triangle inscribed in circle O, which means all three vertices of the equilateral triangle need to be on the circle. And if you think about that, what that really means is, how could we divide a circle into three equal arcs, right? If you divide an entire circle 360 degrees into three, you get 120. So we're really trying to create 3 120-degree arcs. Well, this is actually not very difficult. So I'm going to begin by putting the pointer on point A and opening up my compass to the radius. And I'm going to lock that in, right? You want to lock in the radius of the circle. And then I am going to draw an arc that intercepts the circle twice. Now I could prove this to you, but I'm going to save that for another day. But these 2 points, which I'm going to emphasize in red, actually create an arc that is 120 degrees. Well, I'm going to move down a little bit here to give myself a little bit more room. So now I'm going to take my compass and measure that exact distance, since we are creating an equilateral triangle. And I'm going to lock that in right there. Then I'm just going to bring down my compass and intersect the circle a third time. We've now created 3 equidistant points on the circle. So I'm going to finish off my construction by connecting. Oh, I'll do it in blue just to make it fancy. There's 1, 2, 3. And there you go. That's one way to inscribe an equilateral triangle into a circle. January 19. Question number 5. In the diagram below of circle O, points K, A, T, I, and E are on the circle. Triangle KAE and triangle ITE are drawn. Arc KE is congruent to arc EI, and angle EKA is congruent to angle EIT. Which statement about triangle KAE and triangle ITE is always true? And then as I skim through the answers, I could see they're really asking, well, are they congruent? Are they similar? Are they right triangles? Are they neither, right? Okay, so I'm going to go back and reread my given information and start marking up this triangle and see what information I can become sure of. All right, well, the first thing I see is that arc KE is congruent to arc EI. So I'm going to mark that up with a little, I'm going to put a slash in the arc here, 1 slash there, and 1 slash there. That means that those 2 arcs are congruent. Now, you might remember that congruent arcs, when you connect them with chords, create congruent chords. So I'm also going to put a little mark there and a little mark there, right on that side of the triangle, because we now have 1 pair of sides in those 2 triangles that we know are congruent. So we're working towards our answer here. Now they're also telling us that angle EKA, remember that's from E, that K is in the middle, so that has to be the vertex towards A. So EKA would be this angle right there. I'm going to put an arc there, and is congruent to EIT. I is in the middle, so that's the vertex. So I'm going to go to the other triangle and put an arc here. Well, that's going to tell me that those 2 angles are congruent. So far we have a side and an angle. Now, if you also remember, a very important theorem for angles and arcs is that inscribed angles are 1/2 of their intercepted arcs. Well, here I'm going to put 2 little arcs right here, and this angle right here, angle KAE. And you can see that angle KAE intercepts arc KE. That means that angle is 1/2 of whatever that arc happens to be. And in the other triangle, we have angle ETI, this angle right here, which is also an inscribed angle. The vertex is on the circle, and the intercepted arc is EI. Well, we already know that arc KE and arc EI are congruent. So whatever they are, those angles are 1/2 of that measure. So those angles also must be congruent. So now, if I just look at one of these triangles, what I have is an angle and then the next consecutive angle, and then a side, right? If I put a little 1 here, you'll see what I'm talking about. Angle 1, angle 2, and then this side, right? They come in that order. And if I go back to the other triangle, it's exactly the same. An angle, and a side. And you might remember that an AAS is congruent to AAS proves that two triangles are indeed congruent. So I'm going to go down and see, well, number 4 must be the correct answer. January 19, number 14. The area of a sector of a circle with a radius measuring 15 centimeters is 75 pi centimeters squared. What is the measure of the central angle that forms the sector? Okay, this is similar to a problem we did in the previous exam, but it's kind of like the reverse problem. Well, there's a couple ways we can go about this, but first let's use the formula. So you might remember that the area of a sector is equal to the central angle out of 360 times the area of the whole entire circle. Remember, a sector is like a slice of the circle, like a slice of pizza, right? Formed by 2 radii and an arc. Well, I see that they're giving me the radius here. So I always like to, on my scrap paper, I'll do it over here, set up a little card. And if they're giving me the radius of 15, there's a lot of things I know about that circle. I know that the diameter is 30 and the circumference is 30 pi. But most importantly in this problem, I know that the area of the whole entire circle is going to be pi r squared. My radius squared, 15 squared, which is 225, times pi. Okay, well, and they've given me the area of the sector. So let's substitute all the information in and see what we can do. So we have the area of the sector, which is 75 pi, is equal to the central angle, which we're looking for in this problem, so I'll make it an x, over 360 degrees, times the area of the whole entire circle, which we now know is 225 pi. All right, so now we really need to use our algebraic skills to solve for x. Well, one thing I know that if I just have products and quotients equal to each other, we can cancel out constants on both sides. So I'm going to very quickly get rid of those 2 pi's, all right? And if we're trying, there's a couple different ways we can do this, but we're multiplying by 225, so why not just divide out my 225 on the right, divide my 225 on the left, and then we have 75 over 225 is equal to x over 360. There's a lot of ways you can go about finishing this problem, but let's just take out our calculator and cross multiply. I know a lot of you are very comfortable with that. So if you multiply 225 times x, we obviously get 225x is equal to, and now I'm going to multiply 75 times 360 and get 27,000. 27,000. And as you can see, the last part of this problem will be dividing by 225, dividing by 225, which is really easy to do in our calculator because we already have the 27,000 there. So I'm just going to divide it by 225, enter, and we get our final answer, which is 120 degrees. 120 degrees, quite answer number 2. Now, I just want to talk about this a little bit more, just because I know that some of you might do this in a slightly different manner. One thing that some of you I know already are doing is once you know the area of the whole entire circle and you have the area of the sector, quite simply, we can just take the area of the whole entire circle, which is 225 pi, and divide it by the area of the slice, the sector, which is 75 pi. Pi's cancel out, and if you can't do that in your head, you could, of course, use your calculator. 225 divided by 75 is equal to 3. Well, what that really tells us is that this slice has divided the whole entire circle into 3 slices. The whole pizza has been cut into 3 slices. Well, if you just remember that a whole entire circle has 360 degrees, if you divide it into 3, you're going to get 120. Number 20. What is an equation of a circle whose center is 1, 4 and diameter is 10? And I could see that all of these answers are kind of in a standard form. Well, once again, we're going to remember that the center radius form of a circle looks like this, right? We take the x and the opposite of our x squared plus our y and the opposite of our y squared equals our radius squared. So what I'm going to try to do is first put this into the simple center radius form and then try to work it out into a standard form. So let's begin down here. So I'm going to start with my x and take the opposite of the x value, which is 1, so x minus 1 squared, plus I'm going to do the y. And my y is over here, so the opposite of my y is going to be minus 4 squared is equal to, now remember, they gave me my diameter of 10. So you do need to remember that if the diameter is 10, the radius is 5, which means in the center radius form, it's going to be equal to the radius squared, which will be 25. Okay. Now let's multiply this out. What's an x minus 1 squared? And you might remember that an x minus 1 squared really means x minus 1 times x minus 1. And if we multiply that out, we end up with an x squared minus 1x minus 1x plus 1, which will give us x squared minus 2x plus 1. You know, once you start doing those a lot, you kind of could skip some of these steps. So I'm going to skip the steps in this case and see if you know what I'm doing here. So this is going to, a y minus 4 squared is going to be a y squared minus 8y plus 16, and it's still equal to 25. Now, when you look at these forms that we have here, you can see that they put it in a form where the x squared comes first, the x's come second, the y squareds come third. So I'm going to kind of do the same thing. And all the numbers that don't have letters get thrown to the other side in this particular problem. So I'm going to bring down my x squared, my minus 2x, and this plus 1, I'm going to bring it to the other side, and it becomes a minus 1. Then I'm going to bring down my plus y squared and my minus 8y, and then take this positive 16, bring that to the other side, and it becomes a minus 16. So when I take 25 minus 1, I get 24, and 24 minus 16 is going to be equal to 8. So this right here should be our final answer. So let's go back up to our responses and look for an x squared minus 2x plus y squared minus 8y is equal to 8. Oh, there it is. Number 1. Okay, January 19, number 27. As shown in the diagram below, secants PWR and secant PTS are drawn to circle O from external point P. Now I like this problem because they drew the picture for us. Makes it easier than a previous problem that we did where we had to draw that ourselves. They give us a little bit more information. If the measure of angle RPS, now that means from R to P to S, and it means that P is the vertex. That means they are talking about this angle right here is 35 degrees. And the measure of arc RS, that's the arc from R all the way to S, is 121 degrees. Determine and state the measure of arc WT. Oh, so now we're looking for this arc. I'm going to make it an X right there. Now, once again, I like to sometimes draw a little picture here, and just so I could kind of remember the theorem, right? And remember that if we take this major arc out here and this minor arc over there, and we talk about angles being X, this theorem looks like the bigger arc minus the smaller arc that are both inside the angle divided by 2 should be equal to that angle. All right, so I'm going to write that down here, but this time you see this is kind of like a backwards problem. So I have 121 degrees, my larger one, minus the minor smaller arc, which is my X in this case, divided by 2 is going to be equal to the angle, which is 35 degrees. Okay, here you always have to be a little bit careful when you notice that you have a negative X in the problem. One thing that I like to do when I notice that I have a negative X in the problem and I'm cross multiplying is that when I cross multiply here, I start with the 35 times 2 and I put that on the left side. 35 times 2 is 70 is equal to 121 minus X times 1, which means it's going to stay the same. So I'm going to have 121 minus X. And now I just do a little bit of a transposition. I say, well, I want my negative X to be positive, so I'm going to bring it to the other side of the equation. I'm going to take my 70 and bring it to the other side. I'm going to do it all in one step. And I get a positive X is equal to 121. And that 70 comes to the other side and becomes a negative. And then to finish off this problem, it's just 121 minus 70. So I'm going to go to my calculator, make sure I get this right. 121 minus 70, enter, is equal to 51 degrees. Now, when I'm here in number 27, and it's not a multiple choice question anymore, I like to be very clear with my final answer. They want me to determine and state the measure of arc WT. So I'm just going to rewrite the question. The measure of arc WT is equal to 51 degrees. Okay, let us continue. Oh, is that all? We are done.